Math 102, example 3.3.2. So before we look at finding zeros, we've got a couple of theorems to get through. The first is the conjugate zeros theorem. And that says if I've got an imaginary number a plus bi is one of my zeros, then its conjugate a minus bi is also a zero. Basically, they come in pairs. Next, we've got the fundamental theorem of algebra. Anything that's called a fundamental theorem is a pretty big deal. So this says every polynomial function of degree 1 or more, just about everything, has at least one complex zero. Now that term complex zero doesn't necessarily mean it's got an I. Complex zero does include the real numbers. So basically this theorem says that every polynomial function of degree 1 or more, which is everything except y equals 0, has at least one zero. Finally, our number of zeros theorem. So here, my polynomial function has degree n, and we're going to say it has at most n distinct complex zeros. Now we say distinct. If we remember quadratics, we did sometimes have repeated roots, so it's the same number more than once. All right, so our first type of problem, we're going to be given one of our zeros, and we'd like to find the others. So here, my zero is -1, and my function is 2x cubed minus 5x squared minus x plus 6. So to find that zero, I'm going to do division. Remember, if the number is by itself, there's no x in front of it, that means I don't change the sign. And then let's put my coefficients. Oops, -1 and 6. All right, so let's do synthetic division. Oh, I apologize, I made a mistake. Let me go back. This is -2. So then I get -7, +7, which is 6, -6, and then a remainder of 0. In our previous section, we saw that if we get a remainder of 0, that means this number is a zero of the polynomial. Well, okay, that's great. That means I didn't lie to you, but I still don't have the other zeros. Let's look at the quotient. That is the quadratic 2x squared minus 7x plus 6. If I set that equal to 0 and solve, that will give me my other two zeros. This is a cubic, so that means I have at most 3 zeros. Now, this one's a little hard to factor, so let's use the quadratic formula. Now, you can actually use the quadratic formula from the quotient and just label it A, B, and C like that. And let me just scroll this down so I've got a little bit more room for my quadratic, which again is -b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Let's see what we get. So I've got 7 plus or minus the square root of 49. 4 times 2 is 8 times 6 is 48. And there's a 4 on the bottom. So that means I get the square root of 1, which is 1. So that means I could have factored. That's okay, I didn't. To solve this a little bit more easily, let's write it as two expressions, one with the plus and one with the minus. And looks like I get 2 and 3/2. Those two numbers should be my remaining two zeros. Now, we can use our calculators to help us with this. So I'm going to graph our given function, and let's see what it looks like. So we can see hopefully pretty easily that -1 is a 0, and looking at the graph at least, it does look approximately like +2, and about 1.5, which is 3/2, are where we cross the axis. So at this point, I'm hopefully feeling pretty confident that those answers are correct. Again, this was degree 3, so 3 zeros total. I was given 1, so that means I need 2 more, which is what I got.